Okay, good afternoon, ladies and gentlemen. My name is Nadim Abdulrahim. I'm part of the global government industry team in Huawei. And today I'm going to talk about major events overall in general, but more I'm going to specialize or look into the visualizing of the data perspective, how we deal with data, a bit on privacy of data also, and really how we deal with artificial intelligence today. When we look at major events, there's a lot of threats and challenges we have. You obviously know most of them, so of course nowadays it's COVID-19, crime, terrorism, public disorder, all kinds of attacks or activists and cyber attacks. In addition, challenges are multiple sites. In all these major events, in this is the case, there's 8 stadiums, for example, multiple parties. So multiple parties being organizing, media, all the events, the hotels, the transportation, all these people which are partly part of the overall solution or not. Many VIPs, diverse crowds from all over the world, temporary staff, of course, systems failures, and so on. Now, other things are having control over your own resources, knowing where they are, being able to manage them, direct them based on events, based on command and control principles. Accommodation for everybody, the logistics, getting people to and from the right places, social media, of course, and integrating with systems. In general, as solutions are being built, they're built over a period of time, of course. So we're talking about 8 stadiums in this case. So they're built over a long period of time. They will have different types of systems inside. So a lot of them would be silo systems or independent systems, but also you have to integrate them to get an overall perspective. Now, when we look at this, how do we manage all of it? So the key part is to get an overall site-wide situational awareness. What is happening, where, at what time, and how to gather all that information. So look at information before an incident happens. So we listen in to all types of devices using cameras, collect information, even in more media, social media, news, and so on. During the incident, of course, you want to respond as quickly as possible to any major event that happens, any incident. Collaborating between multiple agencies, potentially. So there's the organizing committee, there is the police, security services for the event in particular, civil defense, and emergency medical services. And all this, we take on an approach what we call intelligence-led policing or intelligence-led collaboration in this case. And this is a bit of what I'm going to concentrate on today. After the incident, of course, you want to do the reporting. You have to have all the data available to do the analysis of what happened, how it happened, and how to improve in the future, and so on. So key parts are collaboration between all the different entities that are actually there. We talk about something called also convergence. So the information comes in many forms. Of course, there's communication via walkie-talkies, for example, physical audio communication. There's a lot of video information and data. So we look at audio, video, data, converging all of it, being able to analyze all of it in real time while it's happening. Adding to it artificial intelligence, connecting everything together to be able to grasp the big data from it, and more importantly also making it repeatable, because you want to apply it in many locations simultaneously to many stadiums, for example. If you just take one example of what you have to manage is nowadays COVID-19, the management capabilities of it. So pre-event, what you have to do, during the event, what you have to do, and even post-event. Nowadays, a lot of it is managed by an app. So Idارة, in this case here in Qatar, is handling this. And it's an important part to actually use that information also to link it, because it has a lot of useful information in it. I won't go through the details of each. But in major event coverage, one of the things you have to look at is how do we actually manage it on a national level. So we apply something called like an onion principle. So the stadium is the center of it, and then you have multiple different layers. If you go to the furthest layer on the outside, it's actually the country. So the airport, the port of entry into the country, You know, what kind of systems we have there, how you track and trace people even when they start to come in. You know? There's a lot of existing solutions, so you have to use that data and benefit from it to be able to analyze. And of course, as you go in closer to the stadium itself, there's concentric layers of you know, convergence of more and more information. So there's of course the infrastructure, the roads, the access control into the stadium, the accreditation, the ticketing, front of house, back of house, and all this stuff. You know? So how do you actually do all that? No, it's a lot of data. Data comes from cameras, so that's facial recognition potentially, license plate recognition for vehicles, behavior, behavior recognition of people. I mean, somebody running, somebody fall down, somebody leave a bag, and of course overall ITS, intelligent transport type solutions. All this information actually helps you analyze, but how do you actually make it happen? This is the key. No? In a lot of these cases, there's artificial intelligence already within each one embedded to improve the accuracy of it. So for AI for license plate, AI for behavior, for ITS. On the bottom, you see also there's a lot of other things we add to it. So ITIRAS is, of course, one. API is Advanced Passenger Information System. So this is a global system used in all airports. So anybody coming to an airport, there's advanced passenger information about everybody. So you have a history, who they are, where they're coming from, and so on. So all this is information you can use. But if you look at it from a traditional point of view, when you look at AI, we're using AI, okay, on a particular type of function, no? And we're saying yes or no. This is the identified license plate, or this is the identified person. No, we're using AI to improve the accuracy, but that's actually the end of it. So we're applying now a new way how to use that data. No, there's all this data available. So how do you can maximize it? So we're applying now a solution where we can add multiple types of AIs together, no, to enhance the actual solution you're trying to create. And I'll give examples so that you understand it better in a second with the video actually. Okay, so there's different types of artificial intelligence solutions, and in this case, I mean, we're using a solution called Parseval. G2K is a German company, which provides this capability. So instead of using just edge technology, so we're combining technology together. It might look a bit complicated. Basically what it is that each one of these boxes is some kind of AI technology, and we're cross-linking them together to give you a more advanced capability of analysis. And basically what we're doing, we're analyzing, we're correlating, no? We're learning. So because as you are correlating, you're actually creating new data. And that data then helps you to learn and analyze it even better. And this is then how we then predict. Now, and a very important part, once you have such a complex kind of thing happening in the background, is you want to be able to visualize it. No? So you'll see here under the understanding the situation, you'll see like it's a flowchart. No? The flowchart is actually how we cross-link different type of AI technologies. No? If, then, how, yes, no, how to correlate and create a new solution. And this comes from different types of algorithms. No? So it can be algorithms in-house, algorithms from third parties, or algorithms from IoT solution. And then we correlate it, use the new data to enhance the solution. So how does this apply to sports and events? Use it in security management, of course. No? Security is a very big part of all of that. Visitor flow management. No? How do people get in and out of stadiums? And the surrounding areas, you know, remember the concentric circles. So we're talking from the hotel to the roads, to the stadium, metro system, transportation systems, and so on. You can create real-time dashboards, so information about what is actually happening inside the stadium. And inside the stadium, for example, you can use cameras. You can use the access control system to know how many people are in and out. But you also use the Wi-Fi system. Wi-Fi system, most people are active now. You know, they're tweeting or taking videos and so on. So any active users, you actually know how many users there are within an area, and you can create a heat map of number of people using Wi-Fi. Access control, ticketing, and accreditation. Who can go where? No, is it just a visitor? Does it have access to back of house, and so on? All these things. And of course, nowadays, compliance with COVID protection. No, different types of processes like I showed a bit earlier. Now the solution is something like, I don't know if you guys heard of a PSIM, Physical Security Information Management Solution. This is one step higher, whereas it's based on artificial intelligence and cross-correlation. And it will give you different types of alarms based on what the AI is analyzing, and then you can take action on it, dispatch it to different types of services, whoever is used to take care of it. So if you look at security management, it's automatic detection of risks, for example, forensic searches, and linking all the standard operating procedures which you would have within organizing such an event. Visitor flow management would be people counting all over. Each one of these would be a special type of technology used to count. Visitor flow management, traffic and parking, of course, comes into it also. Now, I'll show you a video now. It's not very long, but in the video you'll see how we are cross-correlating, for example, 2 or 3 AI technologies to improve the result of the main, what we're trying to achieve. Okay, let's say crowd detection first. So in crowd detection, here we see a square where we're detecting number of people. And we're using one technology to detect the number of people. But simultaneously, we have another solution there where we're detecting the number of feet. And we use then the number of feet and the number of people simultaneously to make sure that we're getting an accurate result. Here, it's we're doing flight control, let's say, where people are running away because something happened. This is a very quick one about somebody falling across a different area, detecting them within a specific area, next to stairs, let's say, or somewhere slippery, a specific area. The last one, unattended objects, quite interesting, whereas usually an unattended object, you just look at the object itself. But here then we're cross-correlating with who was next to the object. And then you can know actually who left the object. And it does that automatically. So we're using 2 algorithms, one for the object and one for the person who was next to it. And this way you can cross-correlate and very quickly find out who actually left the object there. So these are ways how you can use multiple algorithms from different manufacturers using this Boolean logic to actually give you much more advanced information and more accurate information. The result of it is then you can recreate dashboards, real-time dashboards of analysis, giving you statistics about overall the digital environment, correlation of analysis, as we said, and we then include data scientists who then can analyze this data to give you new data, basically. Access control and e-ticketing, we spoke about already. This links, of course, to COVID control also. Using, if you're wearing a face mask, temperature checking, and proximity of people, the distance control. Some of the references we've done with these solutions is specifically in Germany, quite a few for UEFA, for the Cup 2020 in Budapest, and several of the Bundesliga clubs. In Middle East also, we've done China, Nanjing in 2013 and 14, Suzhou Police in 2015 for the G20. These are all large mega events, not specifically only sporting events. The Super League in Pakistan for cricket. And maybe the last thing I will touch on is also privacy. Now, when we're talking about data, you have to also, make sure that the data is still being handled the way it should be according to GDPR, for example. So we do the PIA, which is a privacy impact assessment. So important parts of a privacy impact assessment is, why are you implementing a solution? So let's say we're putting cameras because we need to maintain safety. We're putting an access control system because, we don't, to make sure who is coming in is accredited and is allowed to come in. So as long as you define the purpose and the necessity, that's part of the privacy impact assessment. The second part is, do we encrypt the information? Is the information that's available, or do we encrypt it to make sure it is safeguarded? Secondly, watermarking. So that's linked to encryption also. Fourth point would be usually retention. So how long do you keep the information? And once you destroy the information, how do you destroy it? Do you just erase it? Do you write over it? Is it first in, first out? This kind of thing. As long as you define all of these, this is how you can comply with GDPR, and you create your privacy impact assessment, whereas anybody who asks questions, then you have answers why it has actually been implemented, and done. Of course, to safeguard the data, you need cybersecurity. No, you have to have a security strategy of how to secure the data itself, an overall audit trail that who has access to the data, who can read the data, who can write the data, who can change the data. No, so as long as there's an audit trail, you're safe again and having the right answers. And of course, then who is processing the data? Is it who's the controller of the data? Who's the processor of the data? And who's actually dealing with it and what is it used for? A very important part of privacy is also the communication and the signage. So you have to tell people what is actually happening in an area, that there is CCTV monitoring, for example, there is access control in this area, and there's restricted areas where you have perimeter protection, for example, or something like this. No? So this is a very quick brief. It's a very big subject, but it's something important to know that, when you do artificial intelligence, there's a lot of data you can collect. You have to make sure you do it in a proper way also. That's it from my side. Thank you.